Okay, so today we're looking at reviewing some of the ideas from 2V vectors. So our learning intention is to gain the knowledge of working with vectors in 2 dimensions, which is the Extension 1 course. So we'll be successful if we can define what a vector is, add and subtract the vectors, define what a scalar multiplication of a vector is, write vectors in column form or component form, calculate the magnitude of a vector, calculate the direction of a position vector, calculate the scalar dot product, determine if vectors are parallel or perpendicular, and calculate the angle between the 2 vectors. Okay. So, a vector is a quantity with both magnitude and direction. It both has a size, a length, and a direction. A position vector starts at the origin. Vectors can be anywhere on the Cartesian plane. When we add vectors, we add it from tail to tip. So we go tail to tip plus tail to tip, and that will give us this tail to tip. So A plus B will give us C. The laws of vector addition is if U plus V will equal the same as V plus U, commutative law. The associative law, U plus V plus W, is the same as adding U plus the sum of V plus W. U plus the zero vector will give us the U, which is the additive identity. And the triangle identity, that's the magnitude, the length of the vector U plus V, is going to be smaller or less than or equal to the magnitude of U plus the magnitude of W. Okay. Vector subtraction. So if we have a negative vector, it changes the direction. It keeps the size the same but changes the direction. So if I add C plus the opposite of B, that will give me the vector of A. Okay. Scalar multiplication. So if we have a scalar, there's my vector U. If I have 2U, it increases it double the amount, or if I have half U, it decreases it by a half. We can write vectors in column form, so 4, 5, or we can write it in component form where we have 4 in the I direction and 5 units in the J direction. I usually represents like the X axis and J represents the Y axis. To find the magnitude of a vector, we take the direction in I and square that, and we add that to the direction in J and square that. The direction of a vector is tan theta over y over x between 0 and 360 degrees. The scalar product and the angle between 2 vectors relate. So the scalar product is u dot v, which is where we have 2 vectors and we multiply the I components together and add that to the product of the j components. Or we can do the scalar product u dot v is the magnitude of u times the magnitude of v times the angle between the 2 axes, the 2 vectors. Then you can rearrange that to have to find the angle between the 2 vectors. Now, parallel vectors are vectors if and only if they are scalar multiples of one another. So if u is equal to k, okay. Let's do some questions. We want to determine the magnitude and direction of a vector 2i plus 2 root 3j. So it goes 2 units in the I direction and up 2 root 3j in the j direction. So the magnitude is going to be the square root of how many units is going in the I direction plus how many units is going into the j direction. So it's 4 units. Okay, that's the magnitude. Okay. Now the direction, we're going to use the formula of tan theta equals y on x. Now y is going to be 2 root 3, x is going to be 2. So what we're looking is for tan theta equals root 3. So theta must be 60 degrees. Okay. All right, and that's the angle that we're talking about. Okay. So we're going to express the vector in terms of components if the magnitude is 6 units and the direction is negative 150 degrees. If the vector is going negative 150 degrees, that means that this angle here is 30 degrees. Okay, so we know that it's going in a negative I component way, so we're going to have a negative I. Now, using exact triangles, right, we're going to have, that's your 30 degrees. Yeah, so we're going to have it going in negative root 3 in the I direction, and it's going to go 1 unit down in the J direction. Okay, now what we need to do for this is we need to figure out what the vector, how much would that be in magnitude. So and that's going to give us 2. Now we actually want a magnitude of 6, so what I need to do is multiply this whole vector by 3. Is 2 lots of 3. Yeah. Let me make sure actually 3 times the length. Yep. So the vector required is going to be negative 3 root 3 I minus 3 root j. Okay. We want to find the scalar dot product if we have I plus 2j and negative I minus 3j. I can write that in column form. So I've got 1, 2, and I'm going to do minus 1, minus 3. So the scalar product is multiplying the I components first and add that to the product of the j components. So that's negative 1 minus 6. So our scalar dot product is negative 7. Okay. All right, we want to find the angle between these 2 points. Okay. So I'm going to let this be u, and I'm going to let this be v. So first thing I'm going to do is I'm going to try to find the magnitude of u. Okay. That's going to be negative 5 squared plus negative 4 squared. So 25 plus 16 gives me 41. So square root 41. And the v component is going to be 4 squared plus 0 squared. So it's going to be 4. Okay. The dot product is negative 5 times 4 plus negative 4 times 0. So I get negative 20 minus 4. Oh no. Plus nothing. Yep. And I'll just draw a quick little example of how this would look. Okay, so I have my vector v, which is going 4 units this way. And vector u goes backwards -5 units and then down 4 units. Okay. And I'm getting this angle here. Okay. We're going to use the formula of cos theta is the scalar product over product of the magnitudes. So we get -20 over 4 root 41. So we get theta equals to 141 degrees, 20 minutes, and 24.69 seconds. So to the nearest degrees will be 141 degrees, which looks good. Okay, so which pair of vectors are perpendicular? So they're perpendicular if and only if the dot product is 0. Okay, so what I'm going to do is going to write these in column forms. So that's 0 in the I direction, but 1 in the j direction. 2 in the I, -2 in the I direction, nothing in the j direction. Well, the scalar product u dot v, well, it's actually going to be the v dot w. So if I multiply those together, I get 0, and I add to this, I still get 0. So v and w are perpendicular as 0 times -2 plus 1 times 0 is 0. Okay, so which pairs of vectors are parallel? They're parallel if and only if they are scalar multiple of each other. So what I'll do is I'll also write these, or they're in component forms. So we get 5 root 3, 5 and 3. So there's no common factors. But this one, -4, 6, has a common factor of 2. So I can take out 2 on the outside. Yep. And it looks like, what about if I take -1? So I get -2, sorry. So that will give me 2, and that will give me 3. Yep, so the V is a scalar of W. Alternatively, I could have taken out -2 out here. So I could have gone -2, 2, and I could have taken out, so that would be -3. Yeah. Where we get a scalar product, scalar of each other. Okay, so that's a revision on the 2 dimensions vectors from the Extension 1 course.